Why, hello again to all my students. I'm glad you came to listen. Our fun and learning never ends. Here's what we're doing today. Areas and volumes of similar figures. Something that we did in chapter 10, but now we're adding volume ratios. Before we get into our ratios, we will first want to see, are these pictures similar? So first we have a 3 and a 6. And we can want to compare that to a 3 and a 6, and a 2 and a 4. So if I simplify each of these fractions, each of these are 1/2, so yes, they are similar. Now I want you to do the second one by yourself. No, these are not similar because when I reduce my fractions here, I would get 2/3 equals 1/2 equals 2/3, which are not all the same. So no. They're not similar. If I look at these two shapes first, I want to look, are these similar? Well, yes. 2/4 is going to be 1/2, 1/2 is 1/2, and 3/6 is 1/2. That means the scale factor is going to be 1/2. Now if I look at my surface area here, surface area is going to be 22 compared to 88. Now if I simplify that, that would be equal to 1/4. And then if I look at my volume, this would be equal to 6/48, which is equal to 1/8. Now if you look at my scale factor compared to my surface area and my volume, I can see now that my scale factor, in order to get to my surface area, I would have to square it, because 1 squared would give me 1, 2 squared would give me 4. Now when I look at my volume, I can see that I still have a 1 on top, but I have an 8 on bottom. So 2 multiplied by itself, how many times would give me 8? That would give me cubed. Now it's not a coincidence. If you look at the units, area is always squared, volume is always cubed. So are the ratios of surface area and volume. If you want to write this down, you can. You do not have to. It's just, again, showing you that the scale factor would be, compare the numbers, the area ratio is squared, the surface area, and the volume ratio is cubed. Here's asking, what's the scale factor from the smaller to the larger? So I'm going to have my smaller number on top. Now if I want to work backwards, this is going to be my volume ratio. So I want to go backwards. So instead of cubing it, I'm going to take the cubic root. Now if you do not have a cubic root button, that's the same thing as 729 raised to the 1/3 power, or 1331 raised to the 1/3 power. And if you plug that into your calculator, you get 9/11. That is my scale factor, so that would be my answer. Now here's a word problem. My lateral area of the two similar paint cans are given. I'm given the volume of one, and I had to find the volume of the other. First step you should always do in these problems, find the scale factor. So if I look at this problem, I'm given 2 area ratios. So in order to move backwards from my area ratio, I have to make sure to first, I'm going to write it out, 425 over 1019. Again, this would be your area ratio, and I want to go back to my scale factor. So in order to get to my scale factor to area, I had to square the number. So in order to go backwards, I have to take the square root of that number. Now round to the nearest whole number. And now we get 21/32. So first find the scale factor. Second thing, since I'm dealing with volume, I want to now find the volume ratio. So my volume ratio is going to be 21/32. This whole thing cubed. So again, volume is always going to be cubed. That means I'm going to take the cube of the top and of the bottom. So this right here would be my volume ratio. It's a large number because my scale factor is a large number. So now I set up my proportion. It's my third step. Write out a proportion. So it says my smaller can is going to be 1,157. I'm putting it up top because that's where my smaller number for my ratio is. And now looky. I have a fraction equal fraction. When you have a fraction equal fraction, you should cross multiply and solve. And once you cross multiply and solve, you would get 4,094 centimeters cubed. That's the volume of the larger. So here's another word problem. So it's saying that a milk bottle is 10 inches high and holds 34 ounces of milk. Ounces would be considered volume. It's a unit of measurement. And this sandwich shop is a milk bottle. So how many ounces could fit in this sandwich shop? Well, the picture gives me how high this is. So what is given here is the 10 over 480. This is going to give me my scale factor. Now if I simplify this just to make life easier, this would be 1 over 48. And again, this is my scale factor. So now I'm going to figure out what is my volume ratio, because that is what I'm dealing with. I'm dealing with volume. 34 ounces is volume. So now I'm going to take the cube of 1 over 48, because that's how you find your volume ratio. And you would get 1 over 110,592. So this is your volume ratio. So I'm going to set that equal to, it says my small bottle holds 34 ounces. And I want to figure out how much ounces would the big bottle hold. And now look at what I got. A fraction equal fraction. Cross, multiply, and solve. And you would get, if you were to put milk in this milk jug, 3760128 ounces of milk. Drink up. That is all I got for you today. Come back next time. I'll still be here.